Hello everyone, hope your quiz went well. Even if it didn't go well, I guess you have to refocus and try to move on. Our last two sections of Chapter 7 will focus mainly on graphing the quadratic. So actually that's not true, it's just really 7.5. It's all about graphing the quadratic. So you need to get out your calculators if you want to do your experimentation on the calculator. You don't have to, you can go by hand, but I'm not going to show it to you. I really want you to try to discover this on your own, play with your calculator a little bit, pause the video when necessary to do the graphs, and then check if you're not sure what you were supposed to discover, then you can listen and I'll tell you that. Notice though in this first bit, what you need a straight edge. Well, kind of. You don't really need a straight edge, but you can get one. You definitely need a calculator, or I guess you don't definitely need one, but you can have one. And then some colored pencils. I'd really like for you to try to follow these colors or just have different colors so you can compare the graphs and you always know which one you're referring to. But it's up to you. So go ahead and pause now, do this on your calculator, and then you can come back and see what you were supposed to discover. Good luck. Okay, so if you graphed it, so notice it says graph the function y equals x squared on your calculator and also on this graph. So I did y equals x squared in black because that wasn't listed. So that's my traditional y equals x squared. It's a parabola. When you plug in 0, 0 squared is 0. When you plug in a 1, 1 squared is 1, 2 squared is 4. This relationship right here, if from the origin it's 0, 0, then I move right one step, up one step. Because 1 squared is 1. When I plug in a 2, I get a 4. 2 squared is 4. So when I move right 2, I move up 4. I'm going to refer to that a lot when I'm graphing my parabolas. Notice I put 5 points on all of my parabolas. I'm going to ask you to make those same 5 points on your parabolas. And a lot of times you won't even need a calculator to graph them if you understand what it is you're supposed to discover today or what you see in your calculator. So what happens? Well, when we did our red graph, if you look at it over here, it looks like it got skinnier, right, or narrower. That's what it looks like. For my blue, then it looks like it got fatter or wider. And if you look at your green, it flipped it upside down, or you could say it flipped it over the x-axis. So it flipped over x-axis or it flipped it upside down. So really, instead of saying skinny, narrow, wide, fat, I really want you to use words like expand and contract. And then I want you to use the words vertical and horizontal. So this number in front of the x squared, not associated with the x, it's associated with the y. So because it's associated with the y, this impacted the vertical dimension of the graph. So it was a vertical expansion or a vertical contraction. If the number was large, like 2, if the number was greater than 1, right, then what happened? Well, it stretched it higher. So those are other words you could use. Stretch or shrink. Stretch or compact. So when I went over 1 unit, instead of going up 1 unit, I stretched it twice as high. When I went over 2 units, instead of going up 4 units like the original, I went up twice as high, up to 8. So that 1 to 1 step and 2 to 4 step became a 1 twice as high, 2 step, and 2 twice as high to 8 step. So this number greater than 1 stretches vertically. It's a vertical expansion or a vertical stretch. If the number is caught between 1 and 0, right, that's a fraction, that's the second example up here, then that is a vertical compression. Sorry, not contraction, but compression. It's a vertical compression, so it's pushing down. If it's a 1/3, we'll look at this direct relationship. Instead of moving a 1 to 1, I move up and 1/3 that distance. Instead of moving 2 to 4, I go move 2 and then 4 times 1/3, which was 1 and 1/3, or 4/3 distance. So I go up 1 and 1/3. 3 should have went all the way up here to 9. 3 to 9, 3 squared is 9, but I only go 1/3 of that distance, which made it 3, 3. So this is a vertical compression, but it does make it look wider. So this makes it look wider, this makes it look narrower. What happens when we put a negative sign in front? Well, that's just a flip over the x-axis. And then if it's a -1, we just simply flip the whole thing over the x-axis. If it's -2, we have to flip and stretch, except now it's stretching down instead of up. Okay, think about that for a little bit. Pause now and do the next set. Okay, so your next one, what you should have noticed in these next 3 graphs was that it shifts left and right. So everything just shifted to the left or to the right. So once again, I graphed y equals x squared here. So let me re-emphasize those steps. From the origin, we went right 1, up 1, right 2, up 4. Remember, right 1, 1 squared is 1. Right 2, 2 squared is 4. And then you, remember, parabolas are symmetrical. This is the line of symmetry, so you can fold it. So it's got to be identical on the other side. This first one in red, notice, how does the number inside the parentheses that is paired with the x impact the graph? Well, it was a -3 in there, so instead of going left 3, we actually did the opposite, so we went right 3 units. So that was a slide to the right. And then here, the number, the blue one, this is not grouped in parentheses, only the x is being squared, which means it must be associated with the y. Notice the y value here, -5, it's associated with the y, but it's not on the same side as the y. Therefore, you do, if it's on the opposite side, you actually do what the sign says. It's a -5, so we shifted down 5 units. Now, if I put 2 of them together, like this green graph, you look at the inside. If it's paired with the x, you do the opposite, which means left 2 units. So notice here we shifted left 2 units. And then this number, it's associated with the y. You do exactly what you see, which is up 4 units. This is an arrow pointing up. So we moved left 2, up 4. Now, what about the width of those graphs? Well, literally, if you took this black one and shifted it over, it would lie exactly on the red. It would lie exactly on the blue, lie exactly on the green. So look, I have 5 points all the time. So when we shifted it to the right 3 units, you do that step, 1 to 1, 2 to 4, 1 to 1, 2 to 4. The green graph, 1 to 1, over 2, up 4, left 1, up 1, left 2, up 4. The blue graph, right 1, up 1, right 2, up 4, left 1, up 1, left 2, up 4. There's my 5 points. I didn't need a calculator. I didn't do any of these graphs with a calculator. You should just be able to graph them on your own. Now again, you discover with a calculator, that's fine. Or you can check with a calculator. So words this time, what have occurred? Well, we've shifted or we slid. You can use the word slide or shift or transform. The only thing it did was it transformed or it slides right and left or up, down. Right, so -3 or +3, if it's paired with the x inside the parentheses, you do the opposite. If this was a minus sign, you move right 3. If it's a plus sign, you move left 3. If it's on the outside, on the opposite side of the y equals, then you do exactly what you see. Up is a plus, down is a minus. Okay, pause again to do your next discovery back here. Or try to answer these questions. Sorry, it's no more discovery. Try to answer these questions here on the back by looking at what you did and then listen for my explanation later. Okay, so number 3 says, without graphing, describe the changes that would occur to the parent graph y equals x squared. So I circled them with color coordinated them. So this negative sign, well, what does that mean? It means it reflects over the x-axis. So remember, the parabola went from opening up to opening down. So that negative sign in front reflects over the x-axis. The negative ones, sorry, the -1 in parentheses, well, if it's in parentheses, it's associated with the x. So you do the opposite, which is you slide to the right 1 unit, right? So it's a horizontal shift to the right 1 unit. The plus 3 on the outside, if it's on the outside of the parentheses, it's associated with y. So therefore you do, if it's on the opposite side of the y, you do the same as what it says. So if it says plus 3, that means you move up 3 units. And then this 2 is on the outside of the parentheses, which means it's associated with y. So that's a vertical stretch. Remember, if it's a number bigger than 1, it stretches it higher or taller. If it's less than 1 or caught between 0 and 1, a fraction, then it's going to be shrinking. So it stretches it twice as tall, but it looks narrower. Okay, so what is that going to look like? Well, I have to shift to the left 1 unit. I have to go up 3 units. So now right here, my vertex is at 1, 3. And then my stretch, I have to go open downwards because of this negative sign, right? So this means I have to open down. So instead of going to the right 1, down 1, I go to the right 1, down 2, because I've stretched it twice as long, twice as tall, but it's the opposite direction. Instead of 2, 4, I go 2, 8, right? So 2, 8. So it's 1 to 2 and 2 to 8. All right, moving on. So what does HK represent? So this is the form you'll see in the book where a does not equal 0. So y equals a times the quantity of x minus h squared plus k. What does h comma k represent? So that represents the vertex of the parabola. Notice, if this is a minus h, it becomes positive in here. If it's a plus k, it remains positive. When would HK be a minimum or a maximum? Well, if the parabola opens upward, then this point is a minimum. If the parabola opens downward, then this point will be a maximum. So if the A is positive, then it is a minimum. If A is negative, then it is a maximum. So A, I'm talking about this right here. I know this is a lot to digest. You're going to have to do the homework to practice it. Okay, let's look at the next one. It says graph y plus 6 equals 2 times the quantity of x plus 1 squared. Notice this form. It's not what you just saw above. What you just saw above was a times x plus h squared plus y. I'm sorry, that should not be a plus h. That should be a minus h. A times the quantity of x minus h squared plus y. So I would have to move my y to the other side. So that becomes minus 6. So what does that mean? That means my HK is negative 1, negative 6. Left 1, down 6. This is my vertex. That is a minimum point. Not that it matters, but I'm just emphasizing that because we just talked about it. Okay, now you can just go with the 5 points. Well, you might say, well, how do I go with the 5 points? You go based on what we just learned. The 1, usually we go right 1 up 1, right 2 up 4, but if it's a 2 here, we're going to stretch it twice as high. Right 1 up 2, right 2, instead of 4, it's 4 times 2, which is 8. Left 1 up 2, left 2 up 8. Or you can find your x and y intercepts. How do you find your x-intercepts? Well, you set y equal to 0 and solve for x. Right? Then you solve for x. So here, y equals 0, 0 plus 6 equals 2 times the quantity of x plus 1 squared. I moved my 2 over by dividing by 2 by each side. And I notice it's like completing the square. So I take the square root of both sides. X plus 1 equals plus or minus root 3. So therefore, x equals negative 1 plus or minus root 3. Plug that into my calculator, and then I can get a better approximation here. So when I go to connect, it just helps me know how wide to make it. Do I have to do that? Not really if you know this 5-point thing. But then on the other hand, we will make you find these vertices, or sorry, yeah, the x-intercepts, when they cross the x-axis. Right, so these are the intercepts when it crosses the x-axis. When does it cross the y-axis? Well, if it crosses the y-axis, we have to set x equal to 0. So it's very easy to do mentally. Set x equal to 0 here, calculate, and there's your answer. At the bottom, it's a little bit tricky. You might want to pause and look at my answer. First, I plug in the vertex for h and k, and then I plug this in for x and y to solve for a, and then I go back and I plug my a in, so I have my a, my h, and my k. The end. We'll talk about it again. Good luck.